Hello everyone, welcome to our course Reinforcement Learning. In this lecture I am trying to explain how greedy algorithm based on incremental step method helps to solve the multi-armed bandit problems. Okay, and here you can see on the right side the step-by-step approach to solve this problem based on the greedy algorithm, and these are the rewards by the every machine is shown here. So now we will discuss step-by-step process. Okay, fine. Now we will work on it. First, see, as per this one, make Q of A equal to 0, N of A equal to 0. We have the three machines, A, B and C, right? So first make Q returns of A equal to 0 and returns of B equal to 0 and returns of the C equal to 0. Similarly, at the initial stage, number of place by the A equal to 0, number of place by the B equal to 0, number of place by the machine C equal to 0 as of now. Okay. Now, as per this one, first I want to take the first reward, that is the 3. That means A participated in the first play and got the reward this one. So, what is the N of A value? So, N of A equal to 1 and what is the reward it is getting? So, reward R equal to 3. Now, we have to update the Q value, that is the return, estimated return. How we calculate estimated return? Q of A equal to, as per this formula, so old Q of A value plus 1 by number of place multiplied by reward minus old Q of A value. That means, what the old Q of A value? 0 plus 1 by 1, R value 3 minus 0, that's equal to 3, right? That's over. Now go to the second reward, that means second play. That means now what is the N of A value? N of A value equal to 2. What is the reward value? Reward value also 2. Now what is the Q of A value? As per this formula, Q of A equal to Q of A, old Q of A. What is the old Q of A value? Now it is a 3. So 3 plus 1 by number of place 2 multiplied by reward 2 minus what is the Q of A value? Old Q of A value, that is the 3. That's equal to, here Q means it is a old Q value, previous Q value, that's it, previous Q values, okay. So that means 3, here 2 minus 3, minus 1 by 2, minus 0.5, that's equal to 2.5. Now coming to the N of A, now I took the third one, that means third play condition. So N of B, that's N of A equal to number of place, that's equal to 3 and reward equal to 4, reward equal to 4. Now what is the Q of A value? Q of A equal to old Q of A. What is the old Q of A value? 2.5. So 2.5 divided by 1 by number of place 3, third play, multiplied by what is the reward? 4 minus what is the old Q of A value? 2.5. So that's equal to 2.5 plus 4 minus 2.5 means 1.5 divided by 3, that's equal to 0.5. 0.5 into 2.5, that's equal to 3. So finally the estimated return by the machine A, that's equal to 3. Estimated return by the machine A, that's equal to 3, right? So similarly, we have to go with machine B. I will write here, go with machine B. So we know, as of now, we know that Q of A we are getting after 3 plays, that's equal to 3. Now we will work with Q of B. So Q of B means, so you can see, so initially Q of B equal to 0 and N of B also equal to 0. Okay, N of B also equal to 0 initially. But if you take this first reward, that means first play considered, then what happened? N of B becomes 1 and what is the reward? That's equal to 6. Now estimate the reward by the machine B. QB equal to Q old B value plus 1 by number of place by the machine B multiplied by reward minus old return value. So that's equal to, old values are zeros. So 0 plus 1 by 1 multiplied by reward is 6 minus 0, that's equal to 6. Now coming to the next play. Now I want to take the second play reward. That means second play reward means n of b equal to 2. And in the second play, what is the reward? Reward equal to 7. Now, so q of b equal to, what is the q old of b? Q old of b means this one, 6. So 6 plus 1 by 2, number of plays 2, reward value 7 minus old return value 6, 7 minus 6, that's equal to 6.5. So finally, return for the q of b, that means b mission is 6.5. 6.5, right? Now we will go with mission C. So, but as of now, we know that mission A reward is 3 and mission B reward is 6.5. Now we are working with mission C. Mission C. So now for the mission C, so what is the initial Q value? Return value 0. There is no place as of now, so NC equal to 0. Now I want to consider the first one. First reward, that means first play reward. First play reward means n of c equal to 1, r equal to 5. Now you have to use the formula q of c equal to old return value plus 1 by number of plays by the machine C into reward by the machine C into old value, old return value. Now you can see here for this case, for the first play, old value is 0 only. So here you can write 0 plus 1 by 1 into reward value is 5 minus old q value is 0. So you have the 5. Now, so what about the, now I want to take the second play reward. So I want to consider the second play. So if you want to consider the second play, n of c equal to 2 and reward equal to 4. Then q of c post second play equal to old value. What is the old value? 5. 1 by NC value, number of plays, that's equal to 2, reward value 4 minus old value, this is the old value, that's equal to 5. So here we have the 4.5. Okay. Similarly, next go to third play, because this machine C participated in the 3 plays. In the third play, you have the reward of 6. So for the third play, reward is 6. That means n of c equal to third play, right? N of c equal to 3, third play, reward equal to 6. Then what about the QC value? Estimated reward by the machine C post third play, that's equal to old return value, that is the 4.5. That means previous return value 4.5, 1 by 3 into current reward value 6 minus 4.5. 6 minus 4.5. So what you have 4.5 plus 6 minus 4.5 is 1.5 divided by 1.5 divided by 3, that means 0.5, that's equal to 5. So this is the 5. So finally q of c at end of the estimated reward by the machine C at end of the third play equal to 5. Now you have noted down everything. So return, estimated return by the A, that's equal to 3. Estimated return by the B, that's equal to 6.5. Estimated reward by C, that's equal to 5. So out of all these estimations, which will be the maximum for the machine B, it has the maximum reward. So we will suggest the player to go with machine B. So I hope you understand the greedy algorithm with the incremental step method in order to identify the best machine to play based on its returns, based on its previous rewards. Return is calculated, estimation is calculated based on the previous rewards. Based on that estimation, we are suggesting that machine B is best to go with to go and play. So hope you understand the how greedy algorithm works for the multi-armed bandit problems. So in the next lecture, I will come up with the implementation using Python. So until then, bye. Thank you.